Good morning, this is your stat sensei, Mr. Spensei, and we're continuing with your order up. This is the exit ticket. We did a hypothesis test for the warm-up. So it says create a 96% confidence interval to estimate the difference in the proportions based on the order in which the shows were listed in the questionnaire. So real quickly, we already know our confidence level. All right, so we probably should go ahead and fill that out. If we have a place for it, and we do, it says confidence level, so that's going to be 0.96. So we know what that's going to be. All right. So what was our information? Well, first off, let's take a look at this. A survey is given to a random sample of students at a university. All right, so that's important. We have a random sample. Included a question about which of two well-known comedy shows, S or F. I think it's Seinfeld and Friends. Other people have told me to study The Simpsons and Family Guy. I really don't know. It is known that more than 4,500 students watch these shows. This is probably my population, which I'll need for conditions. The students were asked the question, do you prefer S or F? The responses are shown below. So 185 chose S and 139 chose F. I can choose whichever show I want. This time, in the previous one, I chose Seinfeld. Here, I'm going to go ahead and choose Friends. So basically, if I do P hat for the first one, P hat 1, it'll be 139 over 324. And we're going to need to record that here in a moment. On the second one, in a follow-up survey, so now we have another second random sample, we have to stick with the same thing, which would be 88 in this case out of 156. It doesn't matter which one you choose. So P hat 2 is going to be 88 out of 156. As long as if you choose Seinfeld here, you have to choose it here. If you choose Friends here, you have to choose Friends here. Make sure that you're choosing the same thing for both of them. All right, so let's go ahead and get that information recorded before we forget about it. So we said, this is for my first sample. This is going to be P1. This is going to be P2. This is actually the order was S or F. S or F. And here it was F or S. All right. So that was our order. And so we said we're going to use the 139 and the 324. And for the second one, we're using Friends again. It's 88 out of 156. All right, so I need to go ahead and calculate P hat. Remember, P hat is just 139 over 324. So 139 divided by 324 is 0.429. So here, about 43% chose Friends. And then over here, it was 88 divided by 156. And over here, it looks like about 56% chose Friends. So a pretty big differential there. Of 541, excuse me. All right. So our conditions. Well, the first condition is random sample, and this is going to be the S or F survey, and this is going to be the F or S, because that's the order they asked the questions. All right, they told us they both were random samples. So the first condition is met, but this is random sample. And this was a larger random sample. It was a random sample of 324. And that was given. And this is a random sample of 156. And that was also given. All right, we have two independent random samples, so we can go ahead and write that down. Two independent random samples. And I'm gonna write the word given. Two independent random samples. And that was given. All right, because we were working with random samples, we have to do the n is less than 10%. So number 3, we're going to have to do it. If it's random assignment, we wouldn't, but with random samples, we do. So in this case, n equals 324. 324 times 10 equals 3,240. And when I look back, the sample size, or not the sample size, the population was 4,500. So it's like, yeah, that 3,240 is less than 4,500. We're good to go. The next one, n equals 156. 156 times 10 equals 1,560. And that's less than 4,500. So that's good to go. All right, the normality condition. So number 4, NP has to be greater than 10, and it's n times p hat 1, which in this case would be also n times 1 minus p hat 1. So n happens to be 324, and p hat 1 is 0.429. And when we multiply that out, we get 139. And that's greater than 10. So that condition is met. And then we have 324 times 1 minus 0.429. Parenthesis 1 minus 0.429. And that's 185. And that's greater than 10. So this case, all 4 met, and also our normality condition was met. This one is large enough to use the normal approximation, but we still have to check for the other side, which is going to be n2. Actually, this should have been n1. This is n2 p hat 2. And that's going to be 156. So 156 times p hat 2 is 0.5641. And that's about 88, close enough. Equals 88. And that's greater than or equal to 10, so that matches. And then we have n2 times 1 minus p hat 2, which is also going to be 156 times 1 minus 0.5641. And we get 68, which is also greater than or equal to 10. All right, our formula. It's a confidence interval. So we need to use the confidence interval formula, which is p hat 1 minus p hat 2 plus or minus z star p hat 1 times 1 minus p hat 1 over n1 plus p hat 2 times 1 minus p hat 2 over n2. So to calculate z star, well, we need it to be a 96% confidence interval. So it needs to be an inverse norm. It's going to ask you for the area, which is 1 minus 0.96 divided by 2. And if your calculator does the left, right, center thing, you're going to want left, and then you want to make your answer positive. second vars, inverse norm, parenthesis, 1 minus 0.96, close parenthesis, divided by 2. It's working for a z-score, so our mean is 0, our standard deviation is 1. There's the left that I was talking about. And I end up getting 2.0537 and positive people, so we're going to write it as a positive. So 0.429 minus 0.5641 plus or minus 2.0537. And under the radical, I'm going to shorten these up. All right, I'm going to shorten these up because I don't think I have enough room. So actually, you know what I can do? I can do this. 0.4290. This is over the sample size of 324. So what's 1 minus 0.4290? 0.571 plus 0.564, shortening it up just a little bit, and 1 minus 0.564, 0.436. And that whole thing is over 156. All right, let's go ahead and run this. So we're going to go stat test, and we're going to go all the way to letter B, 2 proportion Z interval. And X is 139 out of 324. Our X2 is 88 out of the 156, and we wanted a 96%. Then we end up getting that negative 2.23, which, and both things are negative, which indicates that there was a change. 0 is not contained, so there is a change. So it is definitely statistically significant, and this shows that, or indicates that order may have, the order the question was asked may have resulted in a change. It could have been something else because it was an observational study, but based on this, it appears that order matters. All righty. Appreciate you watching, and I hope to see you on the next one. Thank you.